The other day, you already solved some radical equations, but in this video, I want to bring up the topic which is called extraneous solutions. I'm going to start out with a pretty simple example, which you can see obviously won't work in the first step, but we're going to ignore the fact that we know that it will not work. Follow usual procedures and show why the answer that it leads to is an extraneous solution. An extraneous solution is an answer which, after your algebraic steps, appears to be a correct solution, but which, when you sub it back into the original equation, does not work properly. So here's a very simple equation. We're not going to be able to find any value of x which has a square root equal to -7, but let's blindly proceed. Take each side of the equation, square it, which leads to x equals 49. Hey, looks like a solution. Well, however, we're going to realize that upon checking, so we go back to the original, take x equal to 49, substitute that in, square root of 49, -7, and we see that, no, that answer doesn't work. That is why that answer, which appeared to be a solution, is called an extraneous solution. And now we'll proceed on to the actual example problem for this video. Suppose you start with x equals square root 2x plus 1, then the square root ends, plus 1. Now the first step in trying to solve radical equations is to isolate the radical. So subtract 1 from each side. X minus 1 equals square root of 2x plus 1. Next, we're going to try to get rid of the radical. And one way to do that is to take the side which has the root 2x plus 1 and square it. But you cannot do that without going back to the left-hand side of the equation and also squaring that side. Now, the right-hand side, the square root of 2x plus 1, when squared, is just simply 2x plus 1. The left-hand side, many students get this wrong, so it might be a good idea for you to actually write it out twice to avoid errors, and then distribute x times x, x squared, x times -1, negative x, then -1 times x, negative x, and finally -1 times -1, which is plus 1. Write out the rest of the equation, gather up some like terms, and realize that this is a quadratic equation, which means we need to get all of the terms to the same side of the equation and 0 on the other side. So subtracting 2x from each side yields -4x, and subtracting 1 from each side leaves us with this equation. Now, to proceed further, let's use factoring. In fact, here we have a greatest common factor of x. So factor that out. Away from x squared leaves you with x, and factoring x from -4x leaves you with -4. Now, when you have a factored quadratic equation, each of the factors might potentially equal 0. So here we have x equals 0. And the other possibility is x minus 4 equals 0, which leads to x equal to 4. So we have two numbers, two values of x, which are apparently solutions, 0 and 4. But we need to check them in the original equation to see if they work. So let's try 0 first. Taking the original equation, substituting x equals 0 in, on the left we get 0. Substituting on the right-hand side, 2 times 0 plus 1, plus 1, 0 equals square root. 2 times 0 plus 1 is 1, plus 1. The square root of 1 is 1, plus 1. and it's obvious that 0 does not equal 2. So that answer, which looked like it might work, but which will not, x equals 0, is an extraneous solution. Now let's try the other possible answer, x equal to 4. Substituting in 4 for x in the original equation, 4 equals square root 2 times 4 plus 1 plus 1. 4 equals square root 2 times 4 is 8, plus 1 is 9, plus 1. 4 equals square root of 9 is 3, plus 1. In fact, this is a valid statement, so x equals 4 remains a full solution.